Hello, and welcome to this episode of Criminal Mischief, the Art and Science of Crime Fiction. I'm your host, D.P. Lyle. Today, I want to talk about blood typing. This is used in forensic science less now with DNA, but it's been around for a long time. So if you're writing your story before the late 1980s, DNA didn't become a useful forensic tool until 1987, thereabouts, and it entered the courtroom both in England and in the U.S. around the same time. In England, with the famous Colin Pitchfork case. You can look that up. It's a fascinating read, and Joseph Wambaugh wrote a book called The Blooding, which is about this case. It was the first conviction based on DNA analysis. But prior to that, we only had blood typing. Not nearly as good as DNA, but extremely useful and also very quick and easy to do, though DNA is getting a lot faster now. This dates back to the early 1900s when a guy named Landsteiner came up with the blood typing system that we call the ABO blood type. And what that means is he tested the antigens and the antibodies within the blood. And I won't go into all the details of that because it is a little complex. But I'll tell you up front, if you pick up either Forensics for Dummies or How Done It Forensics and read either one of those books, this is all explained in great detail. And everything I'm going to cover today is in there. So you can pick up those and dig a little bit deeper into this. But the ABO system means that there's 4 types of blood. There's A, there's B, there's AB, and there's O. And these are easy to determine now. As I've said in lectures before in this series, that the general pathway that scientific processes and understandings come to the forensic science world is that first they become a basic science. In other words, a scientist figures something out. Roentgen developed X-rays. Landsteiner developed the ABO system. Its next evolution is that it enters the medical world. X-rays were used in medicine, of course, and blood typing was used in medicine. And it basically helped solve one of the major problems, and that was transfusions. Back in the day, they had to just give blood to people when they figured out how to do it and that they could do it, but they didn't know how to match it. Today, we do serious typing and what's called cross-matching. So you not only take the type of blood, say A negative, and you find A negative on the shelf, the patient's bleeding and you need to give them blood. But you go a step further in that you start testing for other antigen antibody problems within that blood. And these have such cool names like Duffy and Kell and all this stuff. But we test for all these antigens that might cause a transfusion reaction. Well, this took years, even decades, to figure out. But it all started with Landsteiner's system. After medicine, then these entered the forensic science world and the criminal investigation world because they found that that things like semen and saliva and blood left at the scene, you could determine the blood type from those materials. Now, I will say that in saliva and semen, it depends on whether the person has secretor status. And I think about 15% of people do not secrete their blood type antigens in semen and in saliva. It can only be found in the blood. But for the most part, it can be found in any. But we're mainly talking about blood here. Blood at the crime scene. So if you can determine the type of the blood, that's very, very useful when you develop suspects. So remember that when you look at evidence, and we'll talk about this in a future lecture, what you're really doing, the evidence does not point towards someone. It basically points away from everyone else. That's really the fundamental key to forensic science. You're trying to eliminate everyone else and the last man standing is the guy in trouble. Or as Sherlock Holmes said, once you've eliminated all other possibilities, the one that's remaining, regardless of how implausible it is the correct answer. Well, that's true in all evidence. I mean, even to DNA and to anything that we do, ballistics examinations, actually firearms examinations, chemical testing, blood typing. All of these things are to eliminate other people. So if you look at the population distribution of the ABO blood types, 43% are type O and about 42% are type A. Well, you can see those two types make up the huge majority of the population. 12% are B and only 3% are AB. Okay? So what that means is if you find blood at the scene that's type B, for instance, 12% of the population, you've eliminated 88% of the population right there because they don't have the right blood type. They could not have deposited this blood at the scene. Now, it doesn't mean they're not the killer. It just means that the blood at the scene did not come from them. So this typing is very cool. Then the next thing that they look at is what's called PGM, or phosphoglucomutase. That is another group of antigens within the blood. And there's several of those. And again, I won't bore you with all the details because it's very complex. But let's just say that PGM number 2 is only like 0.18% or even less of the population. So if you get someone who is, say, AB blood type and their PGM2, well, you've eliminated a huge amount of the population. Basically, you're down to 2 per 1,000 people. So what that means is that if the suspect and if the crime scene blood are both found to be AB PGM2, it means that only 2 people out of 1,000 could have left that blood there, with the suspect being one of those 2. Well, that's not exactly very good, because what if you're in a city of a population of 1 million? That's not very good. But what you've done is you've eliminated 998 of each 1,000 people in that population. So that's a huge step. So blood typing can exonerate people, or at least suggest that they are not the person that left the blood at the scene. And that can be huge. On the other hand, if the blood type's there, then that person remains in the suspect pool. Remember, this is all pre-DNA. So this can all be done with simple blood typing. But how do we get our blood types? Where do they come from? What makes one person O and another person A and another person B? How does all this work? Well, we have to come to the concept of genotypes and phenotypes. Now, a genotype means what your genes look like, and a phenotype is what you look like. So if your genotype says you're going to have blue eyes, then you're going to have blue eyes. In blood, your genotype, in other words, what you have inherited from your parents, determines the blood type that you have. Okay, fine. Now, in blood typing, in our blood type, we get one gene from each parent, and they pair up, and that pairing determines what your phenotype, what type of blood you're going to have on testing. Okay, so each parent could be A, B, AB, or O. That's possible. So now they can donate one of their genes to the offspring. Well, okay. Another concept you need to know is what's called dominant and recessive genes. Well, A and B are what we call codominant, meaning they're equally dominant. So if someone receives an A gene and an O gene, one from one parent, one from the other, and their genotype is AO, they're going to have A-type blood. If they receive a B from one parent and an O from another parent, B is dominant, O is recessive, their blood type's going to be B. Now, they could also get an A from each parent and a B from each parent, and that would determine their blood type, and that's easy to see. If they get both, if one parent donates an A and another parent donates a B, then they got AB blood type. And if both parents donate O's, and that's required, both parents must donate O types, then they have O type blood. If either parent donates something else, an A or a B, then that takes precedence and that changes the blood type. So at the end of the day, what are we talking about here? This is all in the show notes that you can see on my website and blog. Type A blood can either be AA, where the child received an A gene from each parent, or AO, where they received an A gene from one parent and an O gene from the other. Both of those will have type A blood. Type B blood can either be BB or BO. First case, B from each parent. Second case, a B and an O, just like A. If they're type AB blood, then they must have received an A from one parent and a B from another. And if they're type O, they must have received an O gene from each parent. They cannot receive something different or that would overshadow it. So this gives us how we came up with our blood types. A gene from each parent and what those letters are, A, B, or O, and how those combine will determine your blood type. So once again, type A can be AA or AO, type B can be BB or BO, type AB must be AB, and type O must be OO. It's actually not that difficult. It's just a lot to absorb. Again, as I said, it's on the website. So how is this used in determining paternity, which is huge? In DNA testing now, if you have DNA from the mother and the suspected father and from the baby, then you can determine paternity virtually 100%. With blood typing, it can get close if you have all of those, but not to that level. It can get very high, but not to that level. But it can definitely exclude someone from having been the parent of the child. Okay? So let's say that both the mother and the father have type A blood, or the mother and the suspected father have type A blood, and they're both AA. Well, that pairing could only produce an AA child. It couldn't produce anything else because each parent, since they have two A's, can only donate an A. They can't donate a B or an O. They can't do it. They don't have it. So all of their offspring would be AA. So if you find the child is AO, this guy's not the father of the child because he couldn't have donated the O and neither could have the mother. Now, if the father is AO and the mother is AA, then the child can either be AA or AO because the father could have donated the O. He also could have donated the A. The mother, being AA, can only donate an A. So we start with an A and we either add another A or an O. So the child can either be AA or AO. Well, if the child turns out to be OO or B, type B blood, this guy is not the father. There's no way. Because where did this B come from? It didn't come from the mother. It didn't come from him. It must have come from someone else. And he is not the father of the child. Let's say that the father, the suspected father, is found to be AO and the mother is AO. Well, what can happen here? What possible children can this pairing make? Well, they could both donate an A, AA. One could donate an A and the other a O. It doesn't matter which one, and it's AO. And they both could donate a O, so it could be OO because each of them have an A and each of them have an O. So depending on which parent gives which gene, that will determine that the child is either AA, AO, or OO. Could be any one of those three. Again, If the child in question turns out to be B of any type or AB, then this father is not the father of the child. It's really quite simple. And again, this is all discussed, and there's diagrams and everything like that in Forensics for Dummies and in How Done It Forensics, and there'll be links to those, and you can read more about this. So the ABO system actually is very useful in forensic science because it's quick and it's easy and it exonerates. And remember, I said in the beginning that the purpose of evidence is to eliminate people. So if you have blood at a crime scene or you have a paternity situation and you test the ABO system and you find that it is not possible that this person either left this blood at the crime scene or fathered this child, then you have eliminated that suspect from the suspect pool, at least as far as the father and at least as far as who donated the blood at the scene. Now, just because someone donated the blood at the scene does not mean that they did the killing. It just means that they bled at the scene, and they may have another explanation for it. That's criminal investigation. That's what your sleuth has to figure out. So blood typing is still around. It's still used. But let's back up a little bit. Let's say you find a stain at the scene, and it looks like blood. It's rusty brown. It's reddish looking. It's on the carpet. There's a body nearby, and you say, okay, this looks like blood. So you sample it, and you take it back to the lab and test it. What's the first question they're going to ask? Is this blood? Could be ketchup. Could be salsa. Could be chocolate. Once they dry, the blood turns reddish brown or brownish brown, and sometimes you can't tell it from a chocolate stain. So they have to test it, and let's say, okay, they find out this is blood. What's the next step? Is this human blood? Because dogs and cats and aardvarks and squirrels and all that bleed too. And so it could have come from an animal. So they test for that, and they say, okay, it's human blood. So now we've eliminated chocolate and salsa and aardvarks. So now we're left with, okay, it's human blood. Whose blood is it? Well, ABO typing offers a quick and easy way of testing that against a suspect. And if there's a mismatch, then it eliminates that person as having bled on that carpet. If it matches, then it means he remains in the suspect pool, and it does not prove anything, but it does not exonerate that person. So he's still in the crosshairs, as it were. That's where DNA testing comes in. That's where we determine that this is or is not this person's blood, because DNA testing is extremely accurate. And so we find out that that he did not do it, or that he did not, or he did leave the blood. And DNA will do all of that. But if you're writing your story in, say, the 1920s, 30s, through the mid to late 1980s, then ABO blood typing is what you had. You didn't have anything else. But it's very, very useful, and it is a great tool. So I hope this helps you understand a little bit about blood typing, what it's all about, how it's used in science and medicine, and more importantly in forensic science. And I hope you can use this in your stories, particularly if they're set in the past. So until next time, this has been DP Lyle talking about blood typing. See you on the next episode.